Hello and welcome back to Math with Mrs. Becker. Today in Pre-Calculus, we are going to start section 3.3, which focuses on quadratic functions. A quadratic function is a polynomial function that has a degree of 2. So what that means is that you have x squared. Our x contains an exponent of 2. The shape of the graph of a quadratic function is called a parabola. And a parabola is a U-shaped graph. Okay, so things that are going to help us as we look at this section. Our parabolas can either open upwards or downwards. Okay, so a parabola that opens upwards would look like this. A parabola that opens downwards would look like this. So all of our parabolas will either open up or down. There is a point that is called the vertex point. The vertex point is the center point. It is either the maximum. If your parabola is opening downwards, your vertex is a maximum because it's the highest point on the graph. Or it could be a minimum. If your parabola opens upwards, your vertex is a minimum because it is the bottom part of the parabola. Every parabola or every quadratic function is going to have exactly one y-intercept. Remember, a y-intercept is where it crosses the y-axis. So every quadratic will touch the y-axis at one point. It can have either 0, 1, or 2 x-intercepts. So I'm just going to draw you some examples. 0, let's say you graph your parabola and it looks like this. This has 0 x-intercepts because it never touches the x-axis. Let's say you graph your parabola and it looks like this. This would have 1 x-intercept because it just touches the x-axis at one location. If I graph my parabola and it looks like this, this is an example of where it has 2 x-intercepts. So it is possible for your parabola to never touch the x-axis, to touch it at one location, or to touch it at 2. When it comes to the y, though, it will always cross one time. The parabola is symmetric. What that means is that you can fold it in half perfectly. And it is symmetric over a vertical line. The vertical line must run through the vertex, and it is called the axis of symmetry. So visually, if I have this as my parabola, this is the vertex, it's the center point. There is a line and it's vertical. Vertical means it runs up and down. So we have a vertical line that if I fold this, it would line up perfect like a mirror image. Now, as we move forward studying quadratics, there are 3 different ways that the form of a quadratic can be written, okay? So a quadratic function, there are 3 different ways that we can look at quadratics. Today, we are going to look at what's called the transformation form. I have also seen this called the vertex form, okay? When you get into college math, most of the time they call this the vertex form. Our book calls it the transformation form because here you can see all your transformations. If you're going left or right, that's adding or subtracting in parentheses. If you're going up or down, that's adding or subtracting at the end. So you know if you have a horizontal slide. You know if you have a vertical slide. You know if you are stretching it vertically, vertical stretch or vertical compression. If you have a number out front that's bigger than 1, that means you did a vertical stretch. If you have a number out front that's less than 1, you did a vertical compression. If there's a negative out front, what happens there is it flips upside down because you have a reflection over the x-axis. Okay, so that's why this is really cool. It tells you can look at it and know all the transformations. Now the polynomial form, okay, that's ax squared plus bx plus c. I've also seen this called the standard form. Okay, so here's the standard form. This is helpful if you are ever trying to factor or you are trying to use the quadratic formula. Okay, tomorrow or our next set of notes, we are going to look at what's called the x-intercept form. That's where you can easily pick out those x-intercepts. So today we'll look at our transformation and our polynomial form. Okay, a, b, c, h, k, s, and t are all real numbers. A can never be a 0. If a were to be a 0, what would happen is you would no longer have x squared. And it is a requirement in order to be a quadratic function, you need a degree of 2, meaning your x has to have a power of 2. So you do have to have an a value. It cannot equal 0. If A is positive, okay, so notice where the A location is. If A has a positive value, then your parabola opens upwards. If A is greater than 0. If A is negative, if A is less than 0, then the parabola opens downwards. Okay, so just by looking at that one value, you already know which direction your parabola will open. Okay, first let's go ahead and look at the transformation form a little further. The transformation form is the most useful for finding the vertex. Remember, the vertex is that center point. For a quadratic function written in this form, the vertex is HK. So when it's written in this form, you can just pick out the numbers. You ask yourself, what are you subtracting? Because notice there's a minus here. What are you subtracting from x in parentheses? That gives you the x value for your vertex. Whatever you're adding or subtracting to the end, that is the y value. Now, if I want to be able to sketch the graphs, besides the vertex, it would be helpful to know, is my graph opening up or downwards? So there we will look at that a value. And then if you know the intercepts, remember your x-intercepts is where it crosses the x-axis. Now you might have 0, 1, or 2 of those. Your y-intercept is where it crosses the y-axis, and you will have one of those. So let's go ahead and look at a couple in transformation form. The first thing I like to do is identify A. A is the number up front. If I look at my transformation form, A is a 2. 2 is greater than 1, so this parabola is going to be opening upwards. Okay? Find the vertex. When you have your equation or your function in transformation form, it's easy to find the vertex. Whatever you're subtracting from x in parentheses, that's the x value for the vertex, so that's a 3. Whatever you add or subtract to the end, in this case it's a -4, that is the y value. Now to find your x-intercepts, what you do is you set the function equal to 0. To find the x-intercepts, rewrite the function, set it equal to 0, and we need to solve. So step 1, I would add 4 over. So 2 times x minus 3 quantity squared equals 0 plus 4 is 4. Divide by 2. X minus 3 squared equals 4 divided by 2 is 2. To cancel a power of 2, you take the square root. Anytime you cancel a power of 2, what happens is you have to include both the positive and negative of the other side. So it's plus or minus the square root of 2. Last, to solve for x, I need to add 3. So x equals 3 plus or minus the square root of 2. Now, since I'm graphing, I want to know what those values are in decimal form. So I just go ahead and calculate it. If I have 3 plus the square root of 2, I have 1 intercept at 4.4 if I round it to the 10th. Then if I have 3 minus the square root of 2, 1.6. So there are your x-intercepts. Your y-intercept occurs, your y-intercept, that's when x equals 0. So if x equals a 0, what I need to do is find y. So you go back to the original and you change the x to a 0. So 2 times 0 minus 3 squared minus 4. Well, order of operations, I have to do the parentheses first. 0 minus 3 is -3. Then you would square. -3 times -3 is +9. If I continue with order of operations, I would multiply before I subtract. 2 times 9 is 18. 18 minus 4 is 14. So this is all of the information. I know my parabola will be opening upwards. Its center point is located at 3, -4. Its y-intercept, where it crosses the y-axis, is at 0, 14. It crosses the x-axis at 4.4 and 1.6. So let's go ahead and sketch the graph. Okay, so I notice going left and right, I can go up to 5. 1, 2, 3, 4, 5. Okay, now going upwards, I have to go up to 14. I'm going to go by 2s. So 2, 4, 6, 8, 10, 12, 14. Here's 14. So let's go ahead, and this would be -2, -4. If I graph the vertex, I go to the right 1, 2, 3, down 4. This is the center point. okay? And in our case, this is going to be a minimum because the graph is opening upwards. My y-intercept is at 0, 14. That's the one time that the graph will cross the y-axis. My x-intercepts, if I go to the right 1, 2, 3, 4.4, it will cross the x-axis. If I go to the right 1 and a little bit, it will cross the x-axis. Go ahead and connect it. You know it's a U-shaped graph. It is a mirror image. Remember, there's that axis of symmetry. It's a vertical line that goes through your vertex. That just helped me to go ahead and extend this because I know it has to be a mirror image. So there's one example in transformation, also known as the vertex form. Let's do one more in that form. Okay, here we go. So the first thing I think it's super helpful to know right off the bat is our parabola opening up or down. A is a negative 4. If A is a negative value, the parabola is going to be opening downwards. Okay, so to me, it's really helpful just to know that starting off. Vertex, where is the center point located? Whatever you're subtracting from x in parentheses, in this case, it's a 2. Whatever you're adding or subtracting at the end, it's a 5. To find your x-intercepts, you take the function and you set it equal to 0. Now from here, I solve, so I'd have to minus 5. Negative 4 times x minus 2 squared equals 0 minus 5 is negative 5. Divide that negative 4, so I have x minus 2 quantity squared equals negative divided by a negative is a positive. 5 divided by 4 is 1.25. To cancel a power of 2, I take the square root of each side. This cancels this, so I still have x minus 2. I cancel the power of 2, so I need to include both the positive and negative, and I have the square root of 1.25. Last step. If I want x by itself, I need to add the 2 over. So x equals a positive 2 plus or minus the square root of 1.25. I am sketching a graph. So yeah, that's kind of cool, but I want to actually know where it's going to be located. So I need to go ahead and calculate. If I go 2 plus the square root of 1.25, I have 3.1 if I round it to the 10th. If I have 2 minus the square root of 1.25, I have 0.9. So those are my x-intercepts. My y-intercept, that is where x is a 0. So what I need to do is go to the original and change the x to a 0. Negative 4, 0 minus 2 squared plus 5. Order of operations, I'll do the inside of the parentheses first. 0 minus 2 is negative 2. Square it. Negative 2 times negative 2 is positive 4. Multiply by negative 4. Positive 4 times negative 4 is negative 16 plus 5. Negative 16 plus 5 is negative 11. So it's going to touch the y-axis at 0, negative 11. So I know that the graph is opening downwards. I know that its highest point, because of its opening down, the vertex is a maximum. Its maximum point is located at 2, 5. It touches the y-axis 11 units down. It touches the x-axis 3.1 to the right and 0.9 to the right. So let's go ahead and plot this. 1, 2, 3, 4. I just have to go 4 here. Now going up and down, I have to go to 11 for my negative, so I'm going to go by 2s. So 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8, negative 10. Okay, so positive 2 up 5. That's the highest point. 0, negative 11. If I go to the right, 3.1. If I go to the right, 0.9. That is enough to sketch. I know that there's an axis of symmetry right here. That would make this a mirror image, so I can go ahead. It is opening downwards just like we said it should. So there are 2 examples of what you'll be doing in that transformation form. The other form that I want to look at today is called the polynomial form, also known as the standard form. It's ax squared plus bx plus c. Notice this is that standard form. This helps us to find the y-intercept. If you want to find the y-intercept, remember you put in a 0 for x. Well, it would cancel that term because anything that would have an x would become a 0. So it is always going to be whatever that constant is at the end. So that's kind of cool. If you are using the quadratic formula, you want it in this format. Here's A, here's B, here's C. If you are factoring, you want it in this format. Okay, so that's where it's helpful. If you are trying to find the vertex, okay, vertex, in order to find the x, what you need to do is go ahead and the formula is x equals the opposite of b over 2 times a. That tells you what the x value for the vertex is. Then to find the y, you simply plug the x value into the original function. So you go back to the original, plug that x in, whatever you get, that is your y value. One more thing, I know I said quadratic formula. Remember when you are looking at quadratics, for x-intercepts, you might have 0, you might have 1, or you might have 2. The number underneath the radical in the quadratic, that's how you know how many solutions you have. If you take b squared minus 4ac, that's the value that goes underneath the radical. If this is a positive value, there are 2 solutions. Your parabola crosses the x-axis 2 times. If b squared minus 4ac is 0, then there's 1 solution. That means it only touches the x-axis at 1 location. If b squared minus 4ac is a negative value, there are no solutions. That means that your parabola will never touch the x-axis. Okay, so just some review things from Algebra 2. All right, let's go ahead and do 2 examples. Okay, here's the first function. First thing I still do is a. A is the first value, it's a 1. 1 is positive, so this parabola will open up. Okay. And I know that I'm going to, at some point, be doing the quadratic formula. So I'm going to go ahead and just say, all right, well, I know A is 1, B is 2, C is 3. If I want to find the vertex, they told me x equals the opposite of B. B is a 2. The opposite of a 2 is a negative 2 over 2 times A. A is a 1. 2 times 1 is 2. So negative 2 over 2 is negative 1. So to find my center point, the x value is negative 1. To find y, you have to go back to the original and fill that in. So negative 1 squared plus 2 times negative 1 plus 3 is 2. So I know that my parabola is opening upwards. I know the vertex. To find the y-intercepts, I take the original and I set it equal to 0. Now, if we could factor it, that would be awesome, but 2 numbers that multiply to 3 are 1 and 3. I can't take 1 and 3 and make them add to 2, so I have to do the quadratic formula. Here's A, here's B, here's C. If I figure out the discriminant, the number underneath the radical first, it's B squared minus 4 times A times C. If I go ahead and calculate this, 2 squared minus 4 times 1 times 3, we get negative 8. This is negative. If you have b squared minus 4ac, if it's negative, there are no real solutions. So no, we have no x-intercepts because this is negative. If this was positive, we would have kept going and found those 2 locations. If it was 0, you would have kept going and found your 1 solution. This is negative, so you get to stop right now. Okay, to find the y-intercept. The y-intercept is when x is a 0. So if I plug in a 0 for x, that cancels, so it ends up being a 3. So here's my sketch. I know it's going upwards. The vertex is negative 1 up 2. I know it crosses the x-axis at 0 and 3. Through your vertex, there is the axis of symmetry. So I know that it's opening upwards, but in order to get another point, any point not on that line, knowing that it's symmetric, it's a mirror image, I can take that point, and if there's a point at 3 units high to the right, there also has to be a point 3 units high to the left. So now I can go ahead, sketch it, it opened up. Okay, 1 more, and that'll be it for the notes today, folks. Step 1, I always go ahead and look. A is the number in front of your squared term. A is a 1. 1 is bigger than 0. It's a positive number, so my graph will be up. Since I know A, I might as well identify B and C. B is 4, C is 5. To find the vertex, the formula is right here. X equals the opposite of B. B is a 4, so it's negative 4. over 2 times a. A is a 1, 2 times 1 is 2. Negative 4 divided by 2 is negative 2. So the x value of the vertex is negative 2. The y value, I have to plug it into the original. So I go ahead and wherever there's an x, I make sure that I have negative 2 in parentheses, so the negative stays with the 2. If I plug that in, I end up with a 1. So there is the vertex. If I want to know the x-intercepts, you set the original function equal to 0. Again, if you could factor it, that would be a good option. But if I look at 5, the only way to multiply and get a 5 is 1 times 5, or negative 1 times negative 5. I can't take either of those options and have it add to a 4. So in order to find my x-intercepts, I have to use the quadratic formula. If I go b squared minus 4 times a times c. Again, if I look at this, 4 squared minus 4 times 1 times 5, I have negative 4. If b squared minus 4ac is negative, there are no real solutions. So I have no x-intercepts. So the graph is never going to touch the x-axis. If I want to find the y-intercept, I've changed x to a 0 in the original function. This changes to 0, this changes to 0, so I have a point at 0, 5. So if I go ahead and graph this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so if I go to the left 2 and up 1, there's a point. If I stay at 0, go up 1, 2, 3, 4, 5, there's a point. That's all that I know, besides the fact that it needs to open up. So that's why it's important that you know here's the vertex. Your axis of symmetry goes through the vertex. Any point that is not on the axis of symmetry can be reflected over it. Now I have enough where I can go ahead and sketch it. The parabola is opening upwards. We said it should be opening upwards. Okay, so here is your assignment. Again, we're just looking at these two forms. Our next set of notes, we will look at the x-intercept form. Your assignment, there are 18 questions in the book where you are just working with this type of thing. You're graphing, you're identifying vertex, x-intercepts, y-intercepts, all of those sorts of things. The assignment can be found on pages 170 to 172. You're kind of skipping around a little bit. I picked 18, okay? This is a notebook check. Remember, a notebook check means that I just make sure that you're putting in the time, you're practicing the skills. So as long as you try every question and have it done on time, you're getting 100%. Where I'm going to grade and make sure that you understand this is the quick quiz. Okay, keep in mind this is 18 questions. Your quick quiz is only 2 questions. Okay, so for the day you only have 20 questions total. This is where I'm going to grade on is it right or is it wrong. Just make sure that you go ahead. You have 1 equation in transformation form, 1 equation in polynomial form. A, what is the value for A? Based off of that, will the parabola open up or down? Find the vertex, identify the y-intercept, identify the x-intercept, and go ahead and graph it. So you guys, that was the beginning of 3.3. I hope you had a great day, and I'll talk to you soon.